WBT. So see, these lines and this line is radial temperature, and where this 34 degrees, suppose say this is the point 34 degrees centigrade, and wet bulb temperature, it is on the saturation line. So this point is wet bulb temperature line. These are the inclined lines. So you extend this line, and this DBT also, where these two are coincide, that point is point number 1. So see, bulb temperature on the psychrometric chart as point 1. Right? Now, next one is mark the outside conditions of air, that is 24 degrees radial temperature. Say this is the time 24 degrees, and extend the line vertically, exactly 90 degrees, and 15% relative humidity. So these curved lines are the relative humidity lines. Already you know, in the psychrometric chart, the curved lines will give the relative humidity line. So this is the 50% relative humidity line. Where these two are coincide, this is point number 2. Right? Are you clear now? Okay. So you got the point 1 and point 2. And from the point 2, next point, that is the third point. Otherwise, you can note that how to locate the point. You have the procedure. First mark the point 1, then second point, point 2, with the help of the data given. Then extend the point 2 line horizontally towards the DBT line. Where it is coincides on the line this 34 degrees, that is point A. Make it a point is A. Right? This is the same thing it is explained here, right? As point 2, locate the point A by drawing a vertical and horizontal lines through point 1 and 2 respectively. So we will get point A. After it is clear, I think. Right? Then, from the psychrometric chart, we will find the specific value of L at point 1. So where is point 1? This is point 1. I think the inclined lines will be there for the specific volume lines. Right? That value is 0.9 meter cube per kg of dry air. It is there in the psychrometric chart. That's why if anybody having psychrometric chart, please go through it. So we got now the specific volume at point 1 is 0.9 meter cube per kg of dry air. Next slide. Then, coming back, so we know the point 1, point A, and point 2. Can we locate the enthalpy 1, enthalpy 2, and enthalpy A? So this is the radial temperature line, already we have taken. Extend this up to, it will give the enthalpy 1. And this is already we know point 2. Then we extend up to this line, then it is enthalpy 2. And point A also we got. To extend this line, that is parallel to the wet bulb temperature lines, then it will give the enthalpy A. Next. So these are the points we have taken. Otherwise you can check also. Enthalpy at point 1 is 90 kilojoules per kg of dry air. And enthalpy at 2 is 48 kilojoules per kg of dry air. And enthalpy at the point A is 59 kilojoules per kg of dry air. Therefore, based on this, we can calculate the mass at point 1. The formula is V1 by the specific volume at point 1, where V1 is given in the problem. Right? Please come to the problem. First slide, I think. First slide. Infiltration load is 14 meter per case. This is volume. Next. So like that, no. M1, that is 14.9 will get 15.56 kg per minute. Up to this clear. Next slide. Then the sensible heat gain due to the infiltration air, the formula is mass into the enthalpy difference. That is M1 into HA minus H2. You know all the values. So substitute these values into this formula, then we will get the 171.16 kilojoules per minute. And if you divide by 60, then we will get the watts power. Okay? Just conversion. This is 2853 watts. And latent heat gained due to infiltration air, same formula, instead of HA minus H2, then H1 minus HA. In this, we will get this value is 482.36 kilojoules per minute. Then if we convert it to the watts, then it will be 8,039 watts. Okay? Next. The sensible heat gain from the occupants, I think the occupants is given in the problem. That is 25 members. So 25% occupants into number of 25% QS, that is heat, into the 25. So 90% will get the latent heat. For column it is given 90 and one more value is latent heat, I think, right? 105. It is given in the problem. So 90 to 25, it is 2250 watts. And like that, total latent heat gain from the occupant, this is the sensible heat, and this is the latent heat. Then the latent heat is say 25%. 105 to 25 is 2625 watts. I don't have the values are correct or not, you can check it. Right? Therefore, the total sensible heat gain in the room, that is sensible heat, R&Ac, is solar heat gain plus sensible heat gain due to the infiltration air plus sensible heat gain from the occupants plus sensible heat gain due to lighting, then sensible heat gain from the other sources. This is all room sensible heat. Therefore, we add all the values, then we will get this 28.153 kilowatts. Okay?
ఫేమస్ తెలిస్తే ఇన్పుట్ ఏమేమి కావాలని తెలుసు అంటే అవుట్పుట్ ఏమేమి కావాలి
లైక్ దట్
అనుకున్నాం. ఇన్పుట్
రూమ్ latent heat. Room sensible heat. Same here.
బిల్డింగ్ అలాగే ఓకే
Room latent heat. It is latent heat gain due to infiltration air. This latent heat gain from the occupants. So it is there. You have calculated value. And then the occupants you have calculated that is 105 to 25. So finally you will get the 10.6 level. Therefore, you know the formula, room sensible heat factor is room sensible heat divided by room sensible heat plus room latent heat. So we will get the 0.725. Right? After this clear? Just calculation formula, you have to substitute these values into the formula. Next slide. Now, coming to your psychometric chart, mark this calculated value of R&Ac, that is room sensible heat factor, that is 0.725, just to have calculated. This value on the sensible heat factor scale as 0.8. So, this is the, in the psychometric chart, this right side totally, there will be a sensible heat factor scale will be there. The right side number. So, I will find should be that is the sensible heat factor line Then you locate the point 725. Right side, totally right side. That is point A. No, S is just that line. Yeah, that is point A. Right? Then A join with point B. That is point B is alignment circuit. That alignment circuit is the standard value, that is 26 degrees deviation and 50% relative. In psychrometric chart, 50% relative line and the 26 degrees diagonal temperature, where these two will be coincide, that is called the alignment circuit. Always, if it is not given also, it is the standard value. It is given, which is the alignment circle 26 degrees and 50% RH. So that is point B. Now, you join this A and B. Right? Exactly. Join A and B. Now, exactly from the point 2, I think you have the point 2, the psychrometric chart. From the point 2, draw a parallel line to AB. Already AB is there. I think you know AB. Parallel to this line, draw a line from point 2 to 5, where this side, possibly left side. That is point 5. Parallel to the, where this coincides, that will be the point 5. The line 2.5 is known as a room sensibility factor. Right? Since the 40% of first side, that is from the outside we are taking, and 60% of the recirculated air after the conditioned space through the evaporator coil. Therefore, mark the mixing point 3 on the line 1 2. I think you know the 1 2 line? 1 2 line. And that is given 3.3. How do you get point 3? If you take it to the 100, 60 plus 40. Right? 60 is the right side and 40 is 6 times and 4 times. Then you look at the point 3. After that is clear. How to look at point 3? That is point 3 is called the mixing point. Then the length 2.3 is equal to length 2 1 into 40% of the fresh air, whatever we are taking. Right? Yeah. Therefore, 2-point line, that is TD6, TD temperature, D is dew point temperature, TD6. Of the coil, we know that the bypass factor of the coil is, and the bypass factor is given. The formula is TD4 minus TD6 by TD3 minus TD6. This is the formula. In this formula, we know the value TD3. Right? That is 28 degrees centigrade. Then, by the trial and error method, we get the TD4 and TD6. I think you know what is trial and error method. Right? At that 0.15 left side LHS and equal to the right side RHS, then you will get the value. You substitute, then you get the TD4 and the TD6. Okay? Next slide. So on the psychrometric chart, TD4 will give 10.4 degrees centigrade and the TD6 will give 7.3 degrees centigrade. I think the figure is not visible clearly. Okay, next slide. Yeah, so that is the dew point temperature, TD6. Last I have seen. Then the capacity of the plant, from the psychrometric chart, we find the enthalpy of air at 0.4. Where is 0.4? Yeah. How to locate 0.4 first part? We know the TD4 value, right? And you draw a vertical line and already we know the line 225 line. Right? Where these two coincide, that point will be in here, point 4. So that is that. And from that point, we extend the vertical temperature, the side line, it will be the enthalpy of. Yeah, that is the enthalpy at that point. So that is H4. It will give the 29 kg of dry air. And the enthalpy at the point 3, already you have located the HC point. Then you can take the enthalpy 3. That is 64.8 kilojoules per 8 kg of dry air. Therefore, the mass is total room heat by the total heat removed. That is, total room heat means already we have calculated. That is room sensible heat plus room latent heat by the H2 minus H4. Therefore, accordingly, we will get the mass value 122.5 kg per minute. Therefore, the capacity of the plant, that is mass into the enthalpy difference, then you can take the value, it is from that value, you will get the 20.99, that is, we will get the 4,388.4 kilojoules per kg of dry air, and 1 ton of refrigeration, you know the value is 210 kilojoules per kilowatt. I think you know, 1 ton of refrigeration is taken at the 210 is a fixed value. You divide into that, then you will get in ton of refrigeration. 1 ton of refrigeration is 210 kilowatts. So like that, you will get the 20.9 ton of refrigeration. Next. So that come back. So like that way, you can draw the psychometric chart, and then you can take the, you can calculate all the remaining points. And then like that, one more problem. The hall is to be maintained at 24 degrees centigrade variable temperature, and the 60 degrees, 60% of relative humidity under the following conditions. The outdoor conditions are 30 degrees variable temperature and the 28 degrees variable temperature. Always outdoor temperature is greater than the maintained temperature, right? Because outside the temperature is more. That's why you should know the difference between outer conditions and indoor conditions. In the previous problem, it is indoor conditions, indoor conditions. Indoor condition is given, that is maintained at 24 degrees variable temperature and 16% relative humidity, and then so this is a outdoor conditions at 38 degrees humidity and 28 degrees variable temperature. Then the sensible heat load in the room. The latent heat in the room, that is 11.6 kilowatts, and the sensible heat is 46.4 kilowatts. Then the total infiltration air is 100 meters cube per hour. Apparatus dew point is 10 degrees centigrade. Then the quality of recirculated air from the hall is 60%. 60% means the remaining thing is fresh air. The remaining 40% is fresh air. Now, you draw your own psychometric chart. When you look at this point, air is mixed with the conditioned air after the cooling load. Find the following. The condition of leaving the conditioner coil, and therefore, and before mixing with the recirculated air. And the second part is the condition of air before entering the hall, the mass of the air entering the cooler, the mass of total air passing through the hall, and the bypass factor of the cooling coil, and the refrigeration load on the cooling coil in terms of refrigeration, that is TR. That is the problem.
ఇలాంటి ఫీల్డ్స్ అండి అవి పెడితే అసెస్మెంట్ ఎంటర్ చేయాలి. అందులో ఏమంటే
So,
స్టాఫ్
as usual,
అప్లోడ్
you have to take what is the given data. Then in this given data, you can draw the line. Okay, this is the
వెబ్సైట్ లో అప్లోడ్ చేసి
inner condition temperatures.
దొంగదైతే నన్ను
That is 24 degrees DBT and 50% relative humidity. And this is the outdoor temperatures, outdoor conditions, 30 degrees DBT and 28 degrees relative humidity. And it is the recirculating air. And then the coolest is outside. And earlier, these two are mixing somewhere. But here now, separately, it is entering in the mixing. So same thing. You just locate point 1 and point 2 based on the data. And then the draw line. And you locate point A and the point B. I think alignment circle. You know how to locate the alignment circle. And then you take the remaining all the values and then find out the next step.
So data entry screens need design
And enthalpy 1
on the table structure.
at point 1 enthalpy 2 at point 2 enthalpy 3 at point 8.
You will know the
Same way, you can calculate the mass of
structure
that
of
air at 1
ఏ డేటా ఎంట్రీ ఎక్కడ కావాలో
13 electron kg per
మనం
hour.
ఏమిటి ఉన్నాయి దీంట్లో ఇదిగా స్టాఫ్
And same thing. Earlier you have calculated the sensitivity between
స్టాఫ్
the rest air.
ఐడి
Then the last is
సో ఆ ఫీల్డ్స్
then the
స్క్రీన్
sensitivity
వస్తుంది.
being the room that RHS. Therefore, you can find out
That
the
is the purpose of your web page.
room sensitivity factor with this formula. Then look at the point is as A.
Validations
Next step.
and చూసుకుని ఈచ్ స్క్రీన్ కు వ్యాలిడేషన్స్ అప్లోడ్ చేసేది.
And this is point A. Then you
అది వచ్చిందండి
locate the
మాక్సిమం రొటీన్
alignment circle that's
అలా రెండు
60
మూడు
degrees.
స్క్రీన్స్ చేసుకుని తప్పులు
DBT and
వస్తాయి.
50%
తర్వాత
humidity.
తప్పులు
Then you locate the
వచ్చిన
point
డేటాబేస్
B and then draw a line.
ఇంకా రిమైనింగ్ థింగ్ ఈస్ టోటల్ రొటీన్. అప్పుడు అందరూ 10 మంది ఉంటే 10 మంది కలిసి ఆడుతూ
Then,
ఉంటారు. ఈ 10 ముందుకి ఈ 10
You look at the point 3 again.
చాలా ఎంజాయ్మెంట్ ఉంటుంది. ఎందుకంటే మొదట ఎంత పెయిన్ఫుల్ ఉంటుంది. ఫస్ట్ స్టార్టింగ్ నేను
From the point draw a line 2 to 3.
ఇద్దరు చేశాను.
Exactly.
తర్వాత ఏమో మెల్లిగా ఇంకొక కుర్రాడు వచ్చాడు అటు ఇటు తిరుగుతూ. వాడు
horizontal line.
వచ్చాడు ఏదో బాగానే ఉంది, వీళ్ళంతా వెళ్తున్నారు తిరుగుతున్నారు రిక్వైర్మెంట్స్ గ్యాదర్ చేస్తున్నారు.
Parallel. The line
సూచన
is line AB. Then you will use the actual room sensitivity factor line.
మనకి గేట్ 15 టైం వచ్చింది.
And then where is point 4? This is the point 4. 2 to 3 is known as R&C line. Draw the line joining the point 1 and ADP. ADP is given. That is operating dew point.
వచ్చిన తర్వాత నాకు నచ్చింది.
This is operating dew point.
అలా తిరిగి మూడో వాళ్ళు
1 and then
పనిచేయని నాలుగో వాళ్ళు
ADP will join all these lines.
వచ్చి ఆ తర్వాత ఏమైంది ఎస్పీ లైన్ మొత్తం
Then
ఈస్ట్
the line to put here is the point 4.
40 మంది ఎస్ఐ అని పిలిచి
Point 4.
మొత్తం ట్రైనింగ్ ప్రోగ్రామ్ ఎస్పీ
This
ఆఫీసర్
point 4 represents the condition of the air in the conditioned coil
కానిస్టేబుల్స్ డేటా ఎంట్రీ చేసి వాళ్ళ పార్టీ
or cooling coil. Before mixing the already we have seen the previous diagram. It is the mixing before.
చాలా ధైర్యంగా వచ్చి పోలీసులు
That's why this point here 4 and 3 is different.
అయితే
From side of the chart, you can take this QB4, that is variable temperature at point 4 and 60 degrees. And the relative humidity at this point is 19%.
3 years ahead వెళ్ళిపోయి అతని టీం లీడ్ అప్పగించారు డిగ్రీ.
And like that, condition of air before we
ఇప్పటికి మాట్లాడతారు.
entering the room. Maybe already 60% is recirculated air during the problem. The remaining 40% is pressurized. And you calculate with this 2 to 5 is equal to length 2 to 4 into 30%. Then you get the value 0.5 represents the condition of air before entering the hall. Trial and error method already have calculated. Then the regular temperature at 0.5 will give 20 degrees, 25 degrees, and the relative humidity will be 70%. The mass of air entering the coil are cooler. Total room heat by total heat removed already have seen. previous problem was same. Therefore, its value is 390 kg per minute. Then mass of total air passing through the hall. This is since the total air passing through the hall consists of air passing through the cooler and the recirculated air from the hall, that is 60%. Therefore, 390 plus 60% of air, high air, will give finally 975 kg per minute. And the bypass factor, it is already, and this is the dry bulk temperature 4 minus operator's dew point by PD1 minus operator's dew point. Finally, will give the point bypass factor is 0.214. And then the refrigeration load and the cooling coil, that is the MC into H1 minus H4, where the MC is calculated previously 390, and this is H1 minus H4, these two H1 minus H4, then we will get finally 80,564 kilojoules per minute, and if you convert it to ton of refrigeration, it will be 88 ton of refrigeration. So, like that way, you can calculate the how to calculate the room load, and what is the procedure to draw the psychrometric chart, and how to locate on the psychrometric chart. Then coming to the air conditioning equipment, already we have seen in the refrigeration equipment also. So, what are the main components in the refrigeration? What are the main components in refrigeration? What are the main components in refrigeration? Compressor, condenser, expansion valve, and evaporator. These are the main 4 components of the refrigerator. And as usual, for the air conditioning also, we have the same components. Next slide. The most common components of air conditioning system are, or maybe any air conditioning systems: compressor, condenser, and the pressure regulating devices, that is expansion valve, alpha tube, means thermostatic expansion valve. These are the models are same. Pressure regulating valve, then the evaporator, then the receiver, dryer, and the accumulator. These are the main components in the air conditioning. Next. Then compressor. Do you know the compressor? It is the heart of the system. Without compressor, we can't do. The compressor can be referred to as the heart of the HVAC system. HVAC means heating, ventilation, and air conditioning. Right? HVAC system. And there is very demand in case of some other countries like Dubai and Saudi. HVAC, if you know very well, then we have very demand, particularly in Dubai, because the temperature is very high there. That's why almost HVAC people will observe the type of countries. The compressors are bolted to the engine and are belt driven by either a V-belt or a separation belt. I think to run the compressor, maybe a motor, electrical motor, and through that maybe by the V-belt or maybe any other means we can run the compressor. The compressor is responsible for compressing and transferring refrigerant gas. So what is happening in the compressor? It is receives the gas from the evaporator and sends to the compressors to the condenser. Okay, sound like it. Next slide. This is the compressor generally, but in the household refrigerator This is maybe vertical, this compressor. Maybe it is coated with black color in your domestic refrigerator. The compressor color is coated with black. Why it is black color? Always see, I think you have studied heat transfer circuit. Why it is black? Okay. Next. So this is the compressor, total parts. And this is the piston. In the high temperature, high pressure gas, it is going to the condenser. Okay, and it is entering low temperature, low pressure fuel and gas from the compressor is installed between condenser and evaporator, right? And it is from the evaporator and to the condenser, because here the temperature is very low. It is shown in the Fahrenheit, but it is converted to temperature, degree centigrade. It is always less temperature before entering to the compressor. And after compressing, generally, maybe if you take the pump also, after pumping the temperature is more, right? So like that way, this is entered through this, and then it is a maybe it is a shaft, cam shaft. Maybe it is a rotary motion. This camshaft is a rotary motion, whereas the piston is moving a reciprocating motion. Right? And this mechanism is here. It is called eccentricity. It is the connecting rod between these two. And of course, these are the piston. This is the piston, and this is oil, because there is a mechanical movement is there. What is the purpose of the oil here? To avoid the friction. Maybe there is sometimes this oil is mixing with the refrigerant also. Then maybe we will get the less temperature, less cooling inside. So that's why it will not mix always. Oil and refrigerant will not mix. Right? So this is the construction of a simple compressor. Next. Okay. So this is the simple, and this is the connecting rod with the piston. If it is a rotary motion, then the piston will give the up and down. Right? This is the suction line. Through this it will be entered, and this is the delivery outside. It will go through this. See here this will be light color and it is red color. Through this it will discharge. There is a valve here, something a small line. It will be open during this enter into the condenser. Right? That's why the temperature is high here. It is shown red color. So these are the parts already we know. This is the suction valve. This is because at the suction side, and the pressure will say the suction pressure and the suction valve. Then the piston come down. This is the cam shaft here, and this is the connecting rod. And this is the piston. And the piston is the same your IC is like. And this is the cylinder volume. This is totally like our IC and cylinder volume. So during the next stroke, that is the compressing, here the valve is closed. This valve is closed and this valve is open. Then through this the high temperature, high pressure gas may be sent into the condenser. Next. So this is the pressure enthalpy diagram. Already 1 to 2, that is the compression process, already we have seen in the refrigeration unit also. Then 2 to 3, 2 to 4 exactly, it is the condensation process. And the 4 to 1, 4 to 1 or maybe 5 to 6, this one is the expansion. And again 6 to 1 it is evaporation. And why this is called pressure enthalpy line, pressure enthalpy chart otherwise. This line is called the saturation line. Right? Are you following or not? And before this saturation line, it is the liquid side, and the after saturation line, it will be a vapor region, and between these two, it is a vapor plus liquid region, liquid plus vapor region. This is exactly the saturated line, where the variance factor is 0, variance factor 1, not 0. So, see, the point 1 is after the saturation line. That means that the condition of the gas, right, after evaporated is the superheated region, because it is not exactly on the line. If the line is somewhere here, then the line may be somewhat different. And if it is there, this side, then the value of enthalpy H here, and if you take this value, and finally if you calculate the COP, that is the H1 minus H4, then what is the effect? Numerator and denominator is reduced, exactly the COP will be decreased. Right? That's why the effect of, again, see, the condenser, after condenser, the point should be on the core, but it is beyond the core. Right? Somewhat is the liquid side. That is called subcooling also. From here to here, it is called subcooling. And here to here, it is a superheated region. What is the effect? What is the effect of subcooling and superheated after the evaporation and after the condenser also? Then what will be finally? What about your COP? That is the effect. In the examination also, what is the effect of subcooling and the superheated? So this is the way how to calculate the enthalpy. Next slide. Next slide. The air conditioning system may be divided into two different types. The high pressure, that is the discharge, you can say, discharge valve, discharge line, discharge side, and the low pressure. High pressure is going towards high pressure side is into condenser. That's why with you discharge, we are discharging the gas to the condenser. That's why discharge line, because it is a high pressure and high temperature also. Then the second side is the low pressure, or the suction side. Suction pressure, low pressure, it is same, because it is after evaporation, and then it is entered into the compressor. Compared to the discharge, it is the lowest temperature. And always remember, the discharge temperature and pressure is the highest temperature in the total process. Right? The total temperature, where we will get the maximum temperature or maximum pressure in the total cycle is discharge side. Discharge pressure and discharge temperature. Next, the compressor is the dividing point between the suction and the discharge sides of the air conditioning system. Next, the suction side of the compressor draws the refrigerant gas from the outlet of the evaporator, because from the outside from the evaporator you have to draw, or you have to send the gas into the compressor. That is the refrigerant gas from the outlet of the evaporator. Once the refrigerant is drawn into the suction side, it is compressed, which is concentrates the high heat in the vapor, rising its temperature. Before entering to the compressor, the temperature of the gas, whatever we have taken outside the evaporator, is more the temperature after compression, and the temperature is increasing because of the compressor. Next, the vapor leaving the compressor must be hotter than the atmosphere, so that while it is the condenser, it will be dissipate the heat that it carries to the cooler ambient air. What is happening in the condenser? Before entering into the condenser or after the compressor, the temperature is same. Right? The condition before entering into the condenser or after discharge or maybe after compressor is same. Here, the vapor leaving the compressor or entering into the condenser must be hotter than the atmospheric temperature. You see, generally we have the refrigerators at our home, right? If you touch the, after compression, you touch the pipe, definitely the temperature is very high. Maybe you feel some hot. Or if you touch the evaporator tube, maybe you feel very cool. Once inside the can of the maybe whatever front car maybe in the room, that means it's the room. Here, the condenser is designed to radiate heat and it's usually located in front of the radiator. Because we are talking about truck here, so that before the room actually. In some refrigerator applications, it may be located on the cab roof also. It's where suppose condition space some air will be coming from the upside also. You can see that. Next step. So this is the just like engine it is. Yeah, this is the radiators, like radiator. Heavy vehicles will have radiator. And these tubes are the condenser tubes. Okay? Next. Generally, this is our domestic purpose. We are using the condenser back side of the refrigerator. You will see this type of these are the small diameter lines are there, some wires like, and this is the coming there from the red is what is that? Liquid region. This is the vapor region. It is coming from the compressor. Okay? And before entering the condenser or after compressor, the temperature is more. And this is the flowing like this, and it is totally converted to liquid. That's why if you touch this condenser tube, because we are having all refrigerator at your home, the top side always, or maybe after compressor, you will feel very hot. And before entering the water to touch, it will be very cool. You see sometimes, if the cooling is very more, very high, then we try to form a small ice on this. Or otherwise, if you see your refrigerator, the evaporator, that is deep freezer, it is forming ice inside. Have you observed? It is called frosting. Why it is happening means that whatever you are keeping the product is lesser. It means that there is somewhat very less. Or if the more load is there, then maybe it will not form. Right? You have to provide more amount of the refrigerant. And if it is outside also sometimes, if it is very, the cooling is very high, then this will try to form ice while there is no on this. That is called frosting. Right? And what is the disadvantage of this frosting? If it is evaporator tube, suppose it will evaporate. The evaporator tube was the same almost, but the cooling is going inside. The temperature is very low. But in condenser, the temperature is high compared to evaporator. So, what is the disadvantage of this frosting? We will discuss that. Why it is. So, this is the white is the vapor refrigerant and the red one is the liquid refrigerant. Next. So, this is the condenser. These are the tubes. Next. This is, you see this clear. So, this is the condenser tubes. One side will be connected to the from the compressor, and next will be connected to maybe to the expansion valve. The condenser must have airflow anytime the system is in operation. This is accomplished by the ram air method or by the engine cooling fan. Maybe it is, we are talking about the radiator. So there will be a fan is there, like your exhaust fan. Before the radiator, there will be a fan is rotating. That fan will cool the air flowing. Suppose if it is a domestic refrigerator, we are not providing any cooling fans. Naturally it will be cool, right? Automatically. Because it will be flowing, that's why because of the air outside temperature it will be cooling. Natural cooling. Or maybe if you want, you can provide a fan that is a forceful cooling. The gas is then cooled and condensed to refrigerant at the bottom of the condenser or condenser outlet. So maybe the pressure is high, but the temperature decreases. Yes, the pressure is constant. You see the pressure enthalpy diagram, the temperature decreases. Yes. Then the pressure regulating valve, that is the expansion valve, the desired temperature of the evaporator is maintained by controlling the refrigerant pressure. Two pressure regulator devices are. Before entering to the evaporator, we are using the pressure regulating valve. This is the pressure regulating valve, right? This is the before coming to the compressor. This is the compressor, and this is the before going to the condenser. These are the two pressure regulator valves. So, what is the suction pressure? What is the desired suction pressure? And what is the desired discharge pressure? Based on that, this will work. Right? These two will be provided. Next. This is also a pressure regulator device. R&Ac tube is used to capture the flow of refrigerant to the evaporator of an R&Ac tube air conditioning system. R&Ac tube means R&Ac mouthpiece. What is that? Flow along the flow measurement. Next. These are the pressure regulating devices. This is the R&Ac. This is called, this line is called R&Ac. This is the 15 degrees, right? What is the difference between R&Ac and mouthpiece? Generally, for studying fluid mechanics and hydraulic efficiency, what is the mouthpiece and R&Ac? When it is projected, then it is R&Ac. It is not projected. Through this also you can discharge. It is mouthpiece. And no room and there is no extension. That is mouthpiece. There is no extension. If you put a pipe on your mouth, if you blow it, then it is a pipe may be there. Then it is a R&Ac. Of course, the discharge may be different. What is the discharge? When you calculate the discharge, with using the R&Ac and using the mouthpiece, there will be different because if there is a length is there, definitely some loss will be there. Because some pipe friction will be there. Right? That's it. So this is the R&Ac tube. The simple restriction load in the liquid line between the condenser outlet and the evaporator inlet. Condenser outlet and the evaporator inlet. And this is the R&Ac tube. Right? So this is the total system actually. This is the compressor. This is the condenser. The red mark is the hot temperature. That's why it's shown red mark. It will be flowing like this. These are the fans actually. Then it will be entered into the like expansion valve or maybe dryer. Then this is the aerified tube.
అవి ఉపయోగపడతాయి.
After that, the line will be blue color. See, the arrow is blue because the temperature and the pressure reduces. And this is called an evaporator. And then if you enter into the accumulator, I will see what is the accumulator. After accumulator, you will enter into the compressor. This is the total system of air conditioning. Our refrigerator is also same. We are heating the products into the evaporator. The total cabin is called evaporator. Same thing, but this is clearly compressor, condenser. This is the extraction of all these two, and then evaporator. And these are the additional equipments like accumulator, dryer, all this. Next. What is time now? Right? Into our warm. Problem. Okay. We will see the next class. The remaining remaining components we will see next class.